Hello. Today we are going to discuss about the sixth module. The first topic in that module is magnetic resonance imaging. These are the topic we are going through. First is basics about MRI and the transmitter unit and its components. The basics. Magnetic resonance imaging or nuclear magnetic resonance tomography has emerged as a powerful imaging technique in the medical field because of its high resolution capability and the potential for chemical specific imaging. When a material is placed in a magnetic field, some of the randomly oriented nuclei experience an external magnetic torque which tends to align the individual parallel or anti-parallel magnetic moments to the direction of an applied magnetic field. This gives a magnetic moment that account for the nuclear magnetic resonance signal on which the imaging is based. This moment is in the direction of the applied magnetic field B0, with the magnetic moment being randomly oriented with respect to one another. The components in the XY plane cancel one another out while the Z component along the direction of the applied magnetic field add up to produce this magnetic moment M0. These are the orientation. There is X, Y, Z plane and the magnetic field is applied in the Z direction. As a result, we get a magnetic moment M0 in the magnetic field applied direction Z. These are the transmitting unit. These are the components you can see in the image. The major components are, first one is magnet. It provides a strong, uniform, steady magnetic field B0. Second part is RF transmitter which delivers radio frequency magnetic field to the sample. Third is gradient system which produces time varying magnetic field of controlled spatial non-uniformity. And the fourth is detection system which is the output signal. And the final component is the imager system. It includes the computer which reconstructs and displays the. We can go through in detail. First is imager system. The imaging sequence in the system is provided by a computer. The computer also performs the various data processing tasks include the Fourier transformation, image reconstruction, data filtering, image display and storage. Therefore, the computer must have sufficient memory and speed to handle large image arrays and data processing in addition to interfacing facility. The next is the magnet. The base field must be extremely uniform in space and constant in time. Also, the time signal to noise ratio increases approximately linearly with the magnetic field strength of the basic field. Therefore, it must be as large as possible. Such a magnetic field can be produced by means of four different ways: via permanent magnet, electromagnet, resistive magnet, and superconducting magnet. And next component is RF transmitting system. The RF transmitting system consists of three parts. First is RF transmitter system, second is RF power amplifier, and third is RF transmitting coil. In RF transmitter system is used to activate the nuclei so that they emit a useful signals. Energy must be transmitted into the sample. This is what the transmitter does. RF power amplifier. These pulses are amplified to a level varying from 100 watt to several kilowatt and offered to the transmitter coil. RF transmitting coil. The coil generates RF field perpendicular to the direction of main magnetic field.